SeeShell is perfectly capable of visualizing data right from your PowerShell pipeline. For example, if I run the get counter command, you may or may not be familiar with this. What it does is it returns a sample of data. In this case, it's returning the percent processor time being used across all of my processors in this machine, and it's returning it as a percentage. So in this case, it's about 45.5% of processor time is being used. And you can see it's got a timestamp associated with it as well. If I use the continuous parameter, it will actually repeat the sampling once a second, showing me the changes in the processor use over time. So this is very handy if you want repeated sampling, but you can see the console is now occupied. I can't do anything else with it. So how do we get that data inside of SeeShell? Well, the first thing I want to do is isolate the counter samples property. And just to show you what that looks like, let me run that command. You can see that it's flattened the output, and instead of having a set of counter samples associated with a timestamp, we now have access to the cooked value property directly. So again, I'm going to run that command again, get counter, pipe it through the select command to isolate the counter samples, and we'll send that directly to the out chart commandlet available in SeeShell. And I'm going to call this chart sync CPU, and let's plot it as a spline. And I want to plot the cooked value by the timestamp for the value. And give this a second to come up. There it goes. And you can see that the SeeShell visualization window is more than happy to plot the data as it comes out of the pipe. If I go back to my console, though, you can see that the console is completely occupied with this task. This pipeline's never going to end because get counter, because of that continuous flag, the get counter commandlet is just going to output data until I tell it to stop, until I force it to stop by hitting Control-C. So if I hit Control-C, you can see I get access to the console back, and I can do PowerShell-y things again, but the data is no longer being updated inside of this visualization. So that visualization is directly tied to the pipeline where the data comes from. However, I have the option of executing that data, collecting that data asynchronously. So let's look at how to do that. I'm going to take the exact same command that I ran before, and I'm going to surround the portion of the pipeline that creates the data with these funny little curly brackets. And by doing that, by closing the command in curly brackets, I create what PowerShell calls a script block. And I'm not going to go into a lot of details about what a script block is, but basically it's a reference to a chunk of PowerShell code. So instead of piping the countersample data to outchart, I'm now piping a script block that tells outchart how to get its data. And I'll plot this on a different chart. We'll call this async CPU, and I'll leave everything else the same. We'll plot it as a spline and plot the same values. So let me go ahead and run that. And once again, you can see that SeeShell is more than happy to oblige us. It's plotting the data as it comes out of the pipe. However, if you look at the console, you can see I still have access to my main PowerShell session, and I can still do all the PowerShell-y things that I need to do. Now, one of the nice things about having this data collection running synchronously in the background is that I can interact with these visualizations from the console. So, for example, let's say I want to extend that visualization that I just created to include the total user time being used by my processors. So I'm just going to rerun the command I ran before, and I'm changing the name of the performance counter, so it'll be collecting a different sample of data. Everything else is the same. I'm using the same chart name, the same type of chart, and I'm plotting the same values. And you can see now I'm getting a second spline of data inside of my async CPU visualization. And it may be hard to notice, but you'll notice the second spline is being updated at a different rate than the first spline, and that's because the two data sources, the data source for each of these splines is independent of one another. So the first command that I ran, where is it? There it is. The first command that I ran to get the processor time samples is being executed independently of the one that's collecting the user time data. And in fact, we could add as many series as we want. Let's capture the percent processor time for just the first processor. And there it is, showing up in green. And you can see it's updating independently of the other two data sources as well.